Hello guys, this is CodeNCode and this is 12th lecture of Java design pattern series. In this lecture, we will be covering one of the structural design pattern, that is the flyweight pattern. All right, it is not very common but very important. So let's see what the flyweight pattern is, when you should use it, how you should implement it, what are the benefits of it, everything. All right, so let's get started. So the definition of flyweight pattern. So the flyweight pattern lets you share immutable and memory heavy state across many lightweight objects. So you can create huge amount of basically huge number of logical instances without blowing up the memory. So if you look at some of the keywords here, those are immutable, memory heavy, and blowing up memory. So all have to do with the memory. So uh, just to give you a high level idea, it will be used where you are trying to save a lot of memory, and you can do that by sharing immutable and memory heavy state. What does that mean exactly? Let's understand that with a proper example. So let's say the motivation for this design pattern. So let's say you are building a 3D or 2D game, right? And in that you have a great scenery which contains a lot of models like trees, bullets, characters, right? If there are some flies and all things like that, a lot of things are there, particle system, right? So a lot of things are there, right? So one of the example that we'll be taking is of tree, right? So you want to create a forest, and that forest will have a lot of trees, right? So now when you want to do that, let's say each field is represented by a class and it has a lot of fields. I have taken out some of the fields like their position, x and y, their height, and of course the texture, the image that will be representing the tree, right? So if we're talking about 2D as of now, but you can replace the same with the 3D model. Now you'll have model and texture separately, two memory heavy states, right? So this, the high resolution image, is a memory heavy state, right? Because the height, position, and position x and y are basically integers or float, 4 bytes each, but this is huge, 1 MB, right? Millions of bytes. Now if you see, if you want to build, let's say, 10,000 of these different trees, you want to have a forest with 10,000 of these different trees. uh, let's say there are different types of trees like oak, pine, birch, right? So you want to have 10,000 of these trees in that forest, right? So how much memory you will be needing is, see, the for each tree I'm taking 1 MB, because 1 MB plus 12 byte is something around 1 MB. So 10,000 trees times 1 MB is 10 GB. This much space will be required, right? Just to draw these models. You see how much space we are taking just for drawing these trees, right? There are other things that the memory need to consider, that the memory need to be free to have those things like logic of the game and things like that, right? But the model itself is taking 10 GB of space without private pattern, right? So we want to save space. How we can do that? So you can do the same using the flyweight pattern, right? So if you apply the flyweight pattern, what it will do, so things which are common, right, and memory heavy, right? For example, the texture, since there are three different trees, so only three different textures are there. Yeah, only three, not 10,000, only three. And now this is actually memory heavy because each texture or high resolution image is of 1 MB or maybe more, right? So this is memory heavy and common, right? This position of each tree and height may be different, so this is not common. This thing is common. So what we can do, we can utilize this information, and instead of each tree having their own image, we are going to share between them, right? So we only need three different images, not 10,000, only three, because each of those 10,000 will be sharing these images. Right. So what you will do, again, the same situation, but this time with flyweight pattern. So what you will do, you will need three images, right? For three different types of trees. Each image is of 1 MB, so 3 times 1 MB, 1. And then we have 10,000 objects representing tree, but this time they won't have this high resolution image, right? They are sharing it, so they won't have it, right? They will only have their their specific data, which is their position and height, and which would be roughly around 12 byte, right? So 10,000 times 12 bytes, and we only need three images this time. So we'll have 3 MB plus 0.12 MB, which is 3.12 MB. So you see how much space we are saving. In the earlier stage, we needed 10 GB of space, and for the same thing to do, same models to draw, we only need 3.12 MB on the RAM, right? So yeah, this is the space where your flyweight pattern will be helping you. Special thing here is that there should be certain common data among the objects, which is high resolution texture image in this case. And what is that? The second thing is you want to save memory, right? And this will be your whole motivation. Now let's also have a look at when you can use it. So first of all, you have many conceptually similar objects like we had in the previous example, many trees, right? Thousand to millions. If it is in the higher order, you'll be able to save a lot of memory. If not, you're just putting in a lot of effort to implement the pattern, and you won't get the same benefit you expected. Right, so it needs to have a lot of objects, similar objects, which could be 1,000 to a million, right? Second thing is the object should share large immutable data, as is seen in the previous example. Yeah, the important thing is the data should be immutable. It's not like it is regularly changing, or and it should not depend on the object. Like we have 10,000 objects, it should be immutable, like and also it should be of course large to save the memory, and then it should be immutable, like and the third thing is it should also not depend on the object, right? It should be independent of the object, like the uh, all of the oak trees will have the same texture. It's not like the tree that is on one position will have different texture of the oak tree, and uh, the tree that is on the other position will have a different kind of oak tree. It should not happen. They should have the data should be common, right? So it should be large and immutable data, so it doesn't change with time. So we can cache it. We can cache it, and then whenever we require, we can get it out of the cache, and then you can utilize it, right? Like the images, as we seen, style, strings, shape, definition, right? Model and all, so things like that. And the third thing is that you can clearly separate the shared and varying data. Varying data is the one that is specific to the model, in our case the tree, their position and the height. Different trees can have different position and different height. I'm talking about the oak tree, matlab specific kind of tree itself, be it oak, pine, or birch tree, right? And the data that you are able to separate, that is common to all of those. Yeah, so you should be able to cleanly separate these two. If you are not able to separate these two, then you won't be able to apply the flyweight pattern, and you are hitting, of course, memory pressure. So we are doing all of this just to save memory, which is a huge deal, right? To save memory. Yeah. So these are the points that will let you know that you want to apply this pattern or not. I hope this is clear. All right, let's look at the structure of the flyweight patterns. What things will be there, right? So first of all, you'll have the interface, which is flyweight, right? So you'll define an interface, and then you'll have multiple implementation of it. Like I can define a tree model, then I can define three different tree models, like oak tree model, birch, pine, that we have defined here. If you want to implement more trees, you can define multiple implementation of it. So you have an interface. Now the intrinsic and extrinsic data, the common and specific data for a single object. For example, for a tree, texture is let me just have a look in intrinsic. I have a little issue with English. Uh, so the one that is shared intrinsic. ठीक है. So the thing is that the intrinsic and extrinsic data, when combined, does some job. In this case, rendering or drawing that tree onto the screen, right? That is rendering. So you will need both of these things. You will need the texture, you will need the position and the height also. So what will happen? You will define the flyweight, right? And then you will define whatever operation that you wanted to do inside this interface. In our case, rendering, right? So we'll define the interface and we'll have a function render, which will accept extrinsic data. which is specific to each tree. That is their height and the position. So all of the extrinsic data, first of all, you will define all of the operations here. Second thing, in the parameter of this, you will define the extrinsic data, right? Why? I'll explain that with the proper example. Now, this is first of all an interface. You can define multiple implementation of it, like oak tree, birch tree, pine tree, right? And in this implementation, you will have the intrinsic data, the one that is shared, right? Right. And then, of course, you need to define the factory, because there can be multiple implementation of the flyweight. You need to define flyweight factory, so that here you can actually apply the caching, and you can cache all of the different type of flyweight objects, right? And then whenever you will need certain object, you can simply ask the factory, because it already has cached those object. If you need it, just ask it. It won't create them again and again. It will create it once, and then you can use it among the 10,000 objects. So basically, you will create three. This will create three different objects: oak, pine, and birch tree. And then for those 10,000 trees or million trees that we are going to draw, each will need one of the tree models, either oak, birch, or pine, right? So it will just create each one object for each different kind of model, and each time when you need it, it will simply return it from the cache, right? Now, finally, the client, it manages or supplies the extrinsic state. So you'll have a client, in our case, game will create a forest. So basically, it will create 10,000 or a million trees. Each time when you are creating a tree, you will pass the extrinsic data, right? So game will decide where each tree is to be placed, right? So game will decide, the client, that what is the position and height of the tree. So the client needs to provide the extrinsic data. How? Let's understand all of these different things with a proper example. And we'll also see the memory footprint, that how much memory is being used. If I implement the same, that means if I create a forest with 10 with a million trees, without using for a flyweight pattern and with using a flyweight. All right, so let's jump into the code editor and let's implement the same. So let's go ahead and implement this. So first of all, let's start. So I have a game in which I have game application, which is the client, the entry point to my game, right? And then let's define the models. We'll start by the tree model. Define the tree model. This is flyweight interface, right? So I've named it tree model. And as I told you, that whatever operation that you will be doing, utilizing the intrinsic and the extrinsic data, you will add those functions here. So we need to render the trees. That's why I have added here. Another thing is that it will accept the extrinsic data, because the flyweight has access to only the shared data, not the extrinsic data. All right. So that's why you will provide the extrinsic data in the function parameter. So this is my flyweight interface. Now I'll add multiple implementations of it. That is pine tree, oak tree, and I have also defined an enum to define the tree type, oak, pine, birch, right? So now I have an oak tree, right? So let me just extend it. Yeah. So I have a tree model, basically flyweight interface. Then I'll define concrete implementations of the tree model. So oak tree. So if you look at here, the concrete implementations have intrinsic data. That is the shared data. That's why you have array of byte to store the texture, right? Now, you'll have a constructor, and then since you are implementing the tree model, right? This is concrete implementation of tree models. So you will override the method. So just override the method, and we are doing nothing here, as we are actually not going to draw the trees, right? Though if you want me to draw the trees on a GUI application, I can do that. Just let me know in the comment section. This is not necessary to show you that how much memory flyweight pattern actually saves. Right. So simple implementation, intrinsic data, constructor, and then all of the method that you have defined in the flyweight. You need to override those. Right. So this is oak tree, this is pine tree, does the same thing, nothing changes. Right. And then we have factory. Right. So we have flyweight interface, we have implementation of the flyweight, now we have flyweight factory. The flyweight factory, as I said, will have will keep those objects cached, right? So I have defined this cache as a concurrent hash map. The thing is that mm, it provides a static method, and we will save all of the models in this cache, right? Called the tree models. Multiple threads may try to access it, so it should be thread safe. That's why I'm using concurrent hash map, which is thread safe. Right. So I provided two static methods. One is private and one is public. So this is the method that will help you get the model. So what kind of model a particular tree is looking for. They can provide the tree type, using which we can find them from the tree models map. Right. If it exists, the compute absent you already know. If it exists, if this model exists, right? If you return that. If not, you can provide the method which will create it, right? So if for a particular key the model doesn't exist, it will create it using this function which I have passed here, right? So the thing is, the get method will give you the model which you are asking for. You can provide the type of it, right? So if it exists, it will return that. If not, it will create that model, save it in the cache, and then return it, right? So you basically are creating one model for each type. That's it. So we have three models. It will create three models only, three objects for three models, right? So we have seen the flyweight interface, concrete implementations, and factory. Now that we have everything, right, understood, let's go ahead and look at the game application. But before that, have I explained this asset loader? Asset loader will basically load the image texture, right? As of now, this is a dummy asset loader which does nothing but returns um, um, an array of byte of 1 MB, right? Of 1 million. Basically, the size of this byte array will be 1 million. So it will be 1 MB, right? So each tree will have a texture of 1 MB. So yeah, this is asset loader, which is being used here. If you need oak tree, I'm creating the oak tree and I'm providing the texture. And asset loader is helping me load the assets. It does nothing, just returns an array of 1 MB, right? So now in this model package, we have done everything. We have defined the Flyweight interface, its implementation, and the factory. Three things done. Now the important part is this is only the model. Now we need the trees, right? So you can define a tree here. So tree is the one you can call this one client actually. It will have intrinsic data and then the shared data, which is the tree model, right? Now you are setting the x and y and height, and then you are setting the model also. And when a draw function is called on the tree, from the model we'll call the render, and render accepts only three things: x, y, and height, right? So the thing is, it will have intrinsic and extrinsic data. This one is actually shared, right? The tree model is actually shared because we have only created three objects, one object for each type, right? So this one is shared among the trees. And then whenever you need to draw the tree, you'll simply call the render method and will pass all of the extrinsic data, right? As simple as that. Now, in the game application, I have defined two methods: initialize game efficiently, initialize game inefficiently. In initialize game efficiently, I'm using the flyweight pattern. So I have gotten the oak tree model. So from model factory, I'm getting the oak tree model. I have a model, I can create a tree. To create a tree, what do you need? You'll need XY height and the tree model, right? So as you can see, I'm creating a forest of a million size, right? For each, and I have created a random number generator. So for each tree, I'm randomly generating their height and X and Y positions, right? Coordinates. Once I have that inside the forest, I'm adding a new tree, right? Passing X, Y height and the model. So this is efficient way because I'm using the flyweight pattern here, right? Each tree shares this model because the model factory only creates one instance of this. So whenever you'll need it, you'll utilize utilize an object which is common among all of the trees. Now here I have defined another method which is initialize game inefficiently, which doesn't use flyweight pattern and it creates inefficient tree. Just to give you an example, I have also created inefficient tree. In this tree, we have intrinsic and extrinsic data together. So each tree will have the texture also along with the XY position and height. So as you can see, XY position, height, and also the texture. We have everything here, right? So just initializing them, and it also implements the render method because I'm implementing the tree model, right? So this is inefficient tree. So if I go ahead and you see here, I have created an object of game application and then I'm calling initialize game efficiently. Then we'll calculate the size. We'll calculate the memory footprint, right? So I've created an object of runtime which will help me calculate the memory. So how much space I'm taking before initializing a million of trees, and then how much space I'm using after initializing a million tree, right? And then we'll print it in MB. So if we use flyweight pattern and we build a million tree, how much space it takes? As you can see, before initializing tree, the program takes 2.9 MB of space. After initializing the tree, it takes 39.87 MB of space. So the difference is roughly 37 MB. Right, this is efficiently. I have initialized it in million trees, and we are still taking only 37 MB of space. Now, if I do this, initialize game inefficiently. So I'm creating a million of trees which are inefficient. That means each tree has its own texture. They're sharing nothing, right? So if I go ahead and do that, if I run this, see, before before yeah, before initializing the trees, how much space I'm taking? The same 2.9 MB, but out of memory error. We are getting out of memory error because because we are not able to initialize a million tree, because we have, of course, our programmers is given a certain memory limit and we have to execute the program in that limit itself, and we are hitting that limit, right? So we can't do that. That's how much space it is taking. Let's go ahead and just build let's say 1,000 trees only. All right, 1,000 trees. So what I'm doing for inefficient game, I'm only building 1,000. Let's go for efficient also. Let's build only 1,000 tree, right? And see what is the difference between these two. If I go ahead and now build it, I'm only adding 1,000 trees inside my forest. So as you can see, before adding the trees, I'm using only 2.9 MB of space, and after that, I'm using 1.34 GB of space, right? So the 10 so the 1,000 trees are taking roughly 1.4 GB of space, right? This is for inefficient one. So if we go for efficient implementation, that is our flyweight pattern, building 1,000 trees, how much space it takes? 1.46, 1.47 MB. You see, 1.47 MB, and certain GB. How much was it? Inefficient, just for building 1,000 trees. Yeah, 1.4 GB of space. See, this is how much you are saving using flyweight pattern. So what you are doing here is that you are sharing the tree model. Tree factory caches all of the objects, different types of objects, and different type of model, oak, pine, birch, and whatever tree, whatever model you will need, this is the shared one. Whatever model you will need while initializing them, you can create it and pass it, right? Single object will be shared among multiple trees, right? That's why you are saving the space. Yeah, so this is how you implement flyweight pattern, and this is how much space it helps you save, right? So yeah, this is it for this lecture. If you have any doubt or suggestion, right, or any query, you can post it down in the comment section. Thank you guys for watching, and till the next video drops, keep coding. Thank you.